In this video, we're going to work on how to simplify negative radical expressions, as well as work with complex and imaginary numbers. So for number one, simplifying negative radical expressions works the same way as regular radical expressions, right? If you saw something like radical 64, you would recognize that that simplifies just to 8. The only difference if there's a negative under the radical is that you just take it out as I to show that it's going to be an imaginary number, and you simplify the same way. But usually we'll see our coefficients out in front, so this simplifies to 8i. If you see something like radical negative 20, you can do the same thing. So bring the negative out as just an I, and think about what 20 would simplify to. And again, remember you're looking for perfect squares that divide into 20. In this case, it's just 4 and 5, and radical 4 turns into 2. I have an I, radical 5. And again, for number 3, if we have a coefficient out in front, it still works the same way. When I bring out that negative to make it 5i in front, I just keep that 5i coming down. I could break 12 up into 4 and 3. And again, if the number is a little bit bigger, you could always go into your calculator and divide it by x and then go to the table. But radical 4 is just 2, and 2 times 5 is 10, so you're left with 10i radical 3. Now, if you're doing operations with imaginary numbers, it's always a good idea to simplify first. So for radical negative 3, I'm just going to simplify that to I radical 3 and I radical 15. Now that I have simplified them, remember the rules for multiplying radicals. Multiply the outsides and multiply the insides. So when I multiply the outsides, I times I is I squared, and when I multiply the insides, 3 times 15 is 45. So usually once you're done multiplying, there's some simplifying that you could still do here. So I recognize that I squared was one of those powers of I, right? I to the 0 was 1, I to the first is I squared is negative 1, and I to the third was negative I. So it looks like this one is the one we're applying here. So this just turns into negative 1 times radical 45, or just negative radical 45. And I just looked to see if I could simplify the radical. I know that 45 is a multiple of 9, and 9 is a perfect square. So I could break it into 9 and 5, and that radical 9 turns into a 3. And I just bring that negative down along for the ride. So remember, when you're multiplying or doing any operation with imaginary numbers or negatives under the radical, make sure you simplify first. Like for number 5. Radical negative 4, well, I know there has to be an I, and 4 is a perfect square because it's 2. And 100 is a perfect square as well. That just turns into 10. Now, imaginary numbers work the same way as if you had an x or a variable next to them. If it's the same I to the same power, you can combine them. 2 i's plus 10 i's together makes 12 i's. But for something like number 6, I notice that both of my radicals aren't simplified yet, and neither of them are perfect squares, so it's going to be a little bit more work. I still do the same thing. I take out the negative as an I, and I go from there. So I'm thinking about 18. That's a multiple of 9 again. And I know 8 is a multiple of 4. So I break it up into 4 and 2 and 9 and 2. That radical 9 turns into a 3. And when I multiply that to my 5, I get 15i. And the only thing I couldn't take the square root of was 2, so that was still under the radical there. And 4 turns into 2. 2 times 3 is 6. I radical 2. So remember the rules for adding and subtracting radicals. You need to have the same number under the radical and the same variable to the same exponent. In this case, we don't have any variables, but we both have an I and have a radical 2. So I can just take these coefficients of 15 and minus 6 and combine those to make 9i radical 2. Now for powers of I, remember those 4 powers of I were the only ones you needed to know. I to the 0 equals 1. I to the first is just I squared is negative 1, and I cubed is negative I. 1i, negative 1, negative I. And the process is we take the exponent and we divide it by 4. So if you do this in your calculator, you end up getting 2.25. And you're looking at the remainder. So you need to recognize that 0.25 is like if I had a quarter left over. So my remainder when I divide 4 into 9 is 1. That 1 represents the exponent of what I'm going to reduce it to. So I to the 9th is the same thing as I to the 1st, which just simplifies to I. So you're always looking for the remainder, and that's going to tell you which one of these to use. You can never have a remainder more than 4, because then it would just go in one additional time. For number 8, I'm going to do that twice. If I take 6 and divide it by 2, I get 1.5. And 0.5 is the same thing as 0.50, so you could see that as 50 cents, or 2 quarters. So I'm going to simplify that I to the 6th to just I squared. So that becomes 4 times I squared, or just 4 times negative 1, or just negative 4. And for I to the 22nd, if I take 22 and divide it by 4, again it goes in 5.5 times, so that's a remainder of 2, so I can change that to minus 7 times I to the 2nd, that's where my remainder goes, and I to the 2nd is negative 1, so this is negative 7 times negative 1, and remember a negative times a negative makes it positive. So my final answer is negative 4 plus 7, which is 3. So sometimes when you're working with terms with I in it, you will end up at a real answer once you're done. And number 9, just a couple more terms to deal with, but it's still the same process. When you divide these in your calculator, you're looking for what the remainder is going to be. So when you do 45 divided by 4, it goes in 11.25 times, and again, that's a remainder of 1. So I'm just going to change that to 2 times I to the 1st, or just I. Minus 1238 divided by 4. If you plug that in, you'll see your remainder is 0.5, so that turns into I squared. Plus 5 times, this one you might even be able to do in your head, because 4 goes into 12 evenly, and 13 would just be 1 more, so that has a remainder of 1. And from here I simplify. 2i minus, well, let's think about this. 12 times negative 1 is going to make that a positive 12, so I'll change that right here, plus 5i. So I can't combine all my terms here, but I am able to combine the 2i and the 5i to make 7i plus 12. However, this is not how you would normally leave your answer. Normally, you'll leave your answer in a plus bi form. So I'm actually going to rewrite this so that my real part is first, and my imaginary part comes second. Now, this is a complex number because it has both a real component and an imaginary component. So let's do some operations with complex numbers. For number 8, the rules of complex numbers work the same as combining like terms. If I'm adding, I can add my real components, and I can add my imaginary components to be left with a complex number. Again, I can't combine those because that 22 doesn't have an I. For number 9, though, for subtraction, just remember to distribute the negative before combining any like terms. And then it works the same way. 5 minus 7 is negative 2, and 6i plus 9i is 15i. Now, for multiplication, it's a little tougher. This is one of those double distribution problems. 2 times 9 is 18. 2 times minus 3i is minus 6i. I times 9 is just 9i. And I times minus 3i, remember that's going to be minus 3, but I times I is I squared. The reason I bring this up, if I combine those like terms in the middle there, is because I squared turns into negative 1, so this really is a negative 3 times a negative 1, which should be a positive 3. And when I combine that with my 18, I end up with 21 plus 3i. So sometimes when you multiply, things will cancel. Other times you'll just need to combine your like terms in the middle and combine your first and your last terms once you've simplified the I squared. For number 11, though, something interesting happens when we do this multiplication. 3 times 3 is 9. 3 times a minus 2 is minus 6i, plus 6i, minus 4i squared. Now you'll notice that when I add negative 6i and positive 6i, it reduces to 0, and all I'm left with is 9. Again, if I simplify that to a minus 1, minus 4 minus 1 makes a positive 4. And all I'm left with is a real number 13. So when I multiply two complex numbers where, notice 3 plus 2i, 3 minus 2i, the only difference is the sign in between them. Those are called conjugates, and when you multiply those, you should get a real number every single time. For number 12, you could either simplify what's in the parentheses first or distribute first. I'm going to choose to distribute. 3 times 4 is 12. Remember to add the exponents for those i's when you're multiplying. Minus 5 I to the 4th, minus 15 I to the 4th, minus 12. So I cubed, again, remember that's just negative I. And if I multiply a positive and a negative, the whole thing is negative, so I'm just going to bring that negative on the outside. When I divide 4 by 4, the remainder is 0, so that just becomes I to the 0, which, if you remember, is just 1, and 1 times 15 is still 15, so I'm not even going to write it there, and just a minus 12 hanging out at the end. Again, minus 15 and minus 12 makes minus 27. However, this is not in a plus bi form, so I'm just going to rewrite it so that the negative 27 is out in front, so that I have my real number in front and my imaginary number in the back. For the last one, notice that this is still a multiplication of two complex numbers. The only difference is you haven't simplified these radicals yet. But since they're both perfect squares, this one's not too bad. That turns into 4i, and radical negative 9 turns into 3i. Remember, the negative under the radical just means that there's going to be an I there. And I do the same thing with my double distribution. 8 times 3 is 24. 8 times 3 again is 24, but now with an I. Negative 4i times 3 is negative 12i. And negative 4i times positive 3i is 12i squared. So 24 and 12 make, again, 12i. And negative 12 times negative 1 is just positive 12. And when I combine all my terms, I'm left with 36 plus 12i. So that's everything from this new unit. We started with simplifying negative radicals, then we moved on to powers of I, and then we worked with complex numbers. So you'll see mostly operations with complex numbers, but you'll still need to know how to do both of those other topics as well.